Yeah, I just. Well, I'll stay in touch still. I mean, I'm, you know,
No, I just wanted to make sure.
yeah. I mean, I haven't worked with anything like that. Well,
Okay, we're going to get started.
oh, gyroscope, right?
Can someone hit the like button back
I've done it.
the bottom button? Stay on it, somebody. Good enough. Thank you. Okay, so we're going to start. We had some trouble there, obviously. Thank you for bearing with us for a moment. All right, so welcome to the April meeting of the United States Astronomical Society. Oh boy, hold on. Here's our agenda for this evening. We'd like to welcome anyone. If it's your first time here, raise your hand, tell us your name, how you found out about us, and what your interest is in astronomy.
Michael Woods and Abby Hung and Jerry, and my kid is interested in astronomy.
Okay, kids, who are you guys?
I'm the kid's friend, and I'm here because I like learning. I'm Annalie, and I want to study astrophysics in college, so that's why I'm here.
Excellent. Anybody first time here, right there?
Mark and Lydia Stovall, I saw it in the JSC Roundup, and we're both interested. She's got her own telescope and wants to learn more.
Excellent. Excellent. Anybody else first time here? No?
Well, this is my second time.
Okay. Anybody else? Okay, good enough. We got to move on.
Round up.
All right. If you guys want to get our email distribution list, then Ron a note for me, tell me, David a note for all of them, or the back there where Stan is. He's got a clipboard and some tear-offs. You can send it. They have those email addresses on them. You can send them there and get all our email distribution list. Speakers. Okay. This time is different, okay, because we couldn't get the other computer to work. This is the mic, so don't wander too far off from this area. But use the mouse that's in this podium here, and use this mouse. Don't use a laser pointer so people online can see what you're looking at. Okay, everybody got that? Okay, our first speaker is going to be Paul, which you wouldn't hear a minute ago. There he is. He's here now. Let me tell you just a little bit about Paul before he runs up here. Paul Lotz studied the skies with a 60-millimeter Tasco refractor as a teen in Colorado. Earned a degree in physics and Greek and Latin, completed a summer internship at NRAO, National Radio Astronomical Observatory, in Mexico, and obtained a master's degree in electrical engineering studying optics. After working on the illumination for photolithography, he served as software engineering manager on the Discovery Channel Telescope project at Lowell Observatory. Pretty cool, huh? And led early software architecture and management efforts for what was then the Large Objects Survey Telescope project. Currently, Paul contributes to a NASA project as contract model-based systems engineer. In February 2024, Paul started imaging the skies with a C-Star S50, and now most often employs a celestron origin. So join me in welcoming Paul Lotz.
Hey, thanks for the opportunity to come back and talk. Earlier, I told you about the S50. So I ended up getting an origin in last July. So this is my experiences with it since then. So. Okay, there we go. All right. So here on the right, of course, is the. I guess it's your right. Yeah, is the telescope, and we'll talk a little bit. That's what we're here to talk about. It's a 6-inch telescope. The optical system is a Rowe Ackerman Schmidt astrograph, so it's designed for photography. Again, like the C-Star, you can't look through it. And it's a fast optical system, f2.2, very fast. So this is the optical tube. What's inside of that? One thing that's inside of it is the camera. It has a 6-megapixel sensor, which is compared to, by the way, the C-Star has a 2-megapixel sensor, so it's some resolution here. The mount for the origin is a modified next star evolution mount. It's more or less the same, except that the Wi-Fi in this case is in the optical tube assembly, not the mount. So you can still use the mount, Celestron tells you, for your other telescopes, but you wouldn't be able to use the Wi-Fi feature that you would be able to with other with a standard evolution mount. There's a cable that you can see here, and that's what you use to connect to the optical tube. It has power and communications through it. And the mount has an integrated lithium battery in it. It says they claim 6+ hours of use time. Actually, I forgot my cable, cover cable, cable. The last time I got 2 half nights and a third, and it didn't die on me yet. So it did that. All right, and then it comes with it ships with a mount, and you could also use the tabletop mount that Celestron sells. And so to start out, you pick one of these, you connect the mount to it using the captive screws on the base, and then you just like this with a dovetail, connect the optical tube with the dovetail onto the mount, and use an auxiliary cable. Then you're done, basically. Pretty great. You're ready to go outside. So now you take it outside, and it's pretty easy to carry, especially obviously if you have the tabletop tripod. But even without that, it's pretty easy to carry. Take it outside, turn it on. The origin focuses itself. Got some alignment. It just points to a few places, uses a plate solver, knows where it is. Meanwhile, you walk back inside, and you turn on your app. Anyway, and then it also, the other thing that the origin automatically does is control the dew heater. So it figures out when you need it and turns it on. All right, so you get back inside or hang out outside. You open the origin app, you wait for the initialization to complete, and you're pretty much ready to go. So, and then you select the target and command to move to that target. You can select the target from a map, which is actually pretty useful. You can also select from a list of targets or search or use enter your own coordinates or select from previous targets. And once you do that, you say move to the position it moves, and you start imaging. You press it says ready to image. You press the button start imaging. Wait till you are happy with the picture and say end imaging. Or alternatively, you could create a schedule. So I've had mixed results with the schedule. Sometimes it doesn't. I haven't been able to get it to work. It might very well be me, but sometimes it does work. So it's very handy when it does. So basically, you say I want to image this object for this time, this object for this time. You can put in some other constraints. All right. As far as other things about operation, there are things you have to do manually. The main thing really is just change the filter. There's not a lot of room here, so they couldn't put an automated filter changer in there. So to do that, basically you go out to pull off the dew shield, which is a little scary, but it's okay. And then you extract the filter holder, and I should say that this will hold, handheld. The hand holder is on the top here that you can see. Anyway, you pull it out, and it's connected with magnets. You unscrew the filter that you have, and you put in you put in a new filter and reverse the process. And that's how it works. So this does lock in with magnets. So there are a couple things. One is that recently people have been asking to have, because they don't really like to do all of this, so they've been asking to have, if Celestron will start selling the holders separately, just put the filter in, and you have to unscrew the filter. So that's apparently happening. And then, so you can buy that. And it does mean that it's scary enough to me that I don't do this. It's not like I switch objects. I usually, if I'm using the nebula filter, I'll use it for the next hour or so, and take pictures of the Mission Nebula. So it doesn't, there's a little bit of hesitation, I guess, to do that, but it does work. It works well. All right, this tip, the instruction manual does not ship with the telescope. They don't even mention the instruction manual, but if you go look in the product page for it, it's right there. So it's not hard to find, but it just finds it odd that they didn't even mention it. I wrote to them and they said, yeah, well, yeah. They figured people would just go get it. So anyway, it's fine. Performance. The main thing is it's efficient. whenever you tell it to go there, it finds the object really pretty much every time. It's centered, sometimes it's a little bit off-centered, but it's always near the center, and it's really quite good. And then it does let you reframe, so first I have a picture of the double cluster here, I want to put it both in, you can do that. And then it's very fast imaging. So 5 minutes for opening. So these are, when you create a schedule and it works, these are the default times that get thrown in there, 5, 10 minutes, and 20 minutes, depending upon your object. And that's about what you start. Sometimes do it longer. And tracking is excellent. So whenever you say start the image, the iterated time is almost always pretty much the elapsed time. We don't have a lot of missed images or anything. It just goes. Oh, and interrupt me anytime you want. Okay, and I would say images look good directly the way I do them. So, and by the way, the images are kind of strange, I guess. They come out as a PNG on an Android, or I think it's JPEG on an iPhone, or that imaging system. So anyway, I have an Android, so it comes out in a PNG, portable nimble network graphics, and that's what I do. But you can take the raw images. They do take up a lot of space on your drive. And download the images out of the box. It downloads with the USB-A drive. I've seen that people didn't like that. It took a very long time to download the file. So I did notice that in the latest release, which is either just came out or is about to come out, they do support anonymous FTP. So probably people will be happy with it. All right, and then as far as sharing photos, you basically go to your gallery either when you take the picture or later, and then you select the image, and you can then at the bottom they give you some menu options to include metadata on the image. So it's things like location, the name of the object, the date, and that's probably most of it. And we'll even put the logo on if you want. But anyway, right now, actually, the latest thing is you can put the date now in the release that this last one anyway. There's a bug in it. It just puts the location and doesn't put the date on. So I report that one. That's obviously a mistake. Anyway, the other thing that it lets you do is you can crop the image, and you really just can make any kind of rectangle you want anywhere in the image. What I would like is that they would have a set of pre-configured images, kind of big, small, and small, bigger, and bigger, or whatever. So it make it easier to compare. But anyway, it works great. And then once you do that, you just say share, and then you can share to whichever app you use. So I use Google Photos, and one thing that annoys me is, at least in this up to now, every time you save the image, it kind of exits the app and then comes back, and then it pauses while it reconnects to the telescope. Is really kind of like that. So that's one thing I would like them to fix. I think they are fixing that. All right. So things that are the telescope's not especially good at least it's not its strength here, are lunar and planetary imaging, because it's a fast optical system. It does all right, but that's not what it's really good at. And it doesn't, so what it does is it stacks images. Again, it's an LTS mount, and it stacks images. Default is 10-second exposure, so you just keep stacking the images. Well, with a brighter planet, you don't really do that. So if you did 10 seconds, it would blow up. So what you do is you can do a snapshot mode. And so it's kind of weird because the images don't appear in the origin gallery, but they do appear, for instance, in Google Photos. And what I do for whenever I'm trying to image Jupiter or Saturn, they're really quite small in the image, but you can zoom in and crop, not on the origin app, but in Google Photos, and it comes out nice. Yeah, cool. And then comet tracking is still the same. You still set your rate, so it doesn't really track comets, but you can still point to it. All right. No support at all for solar imaging. I actually asked Celeste on that before I purchased the telescope, and they said, well, no, we have two things. We don't make a solar filter, and secondly, and solar filters that work with it don't work. Their other telescopes won't fit this origin, and also we don't plan to make one. And one of the things is that it doesn't do the initialization because it can't do the essentially you can't do the plate the plate solver in the daytime course, and it doesn't just automatically know where you are otherwise. So they you could make your own solar filter. You could point it to the sun by your own, and you can take pictures, but they won't support it as part of the telescope. And they do say you can use it for daytime. I actually have never done it. And I probably wouldn't take it hiking because while it is portable, it's a little bit large to hike with. So, yeah. So the other thing is, whenever I first got this thing, I would say it was a bit challenging to connect to it with the Wi-Fi. I don't know, maybe it's improved since then. What I do though is get a range extender, which does work well, and then I figured out finally, my brother helped me put this into a mesh network, and now I can be anywhere in the house and connect to the telescope outside if I'm there, or you connect to it directly if you are out. It's its own Wi-Fi server out in the wild. Okay, and I talked about the app connecting and disconnecting and reconnecting. Don't really like that. And the other thing, especially early on, was sometimes for whatever reason it would be going on, and then the app would basically be more or less unresponsive, and it would be very slow or extremely slow. But if you just exit the app and come back in, it starts working again. So it's really not that big a deal. But anyway. So here's the tips. My tips on if you do acquire this thing and you do carry it somewhere and you're going out there to State Park or whatever, the optical tube assembly, the origins of it sometimes sells a carrying case specifically for this. I guess if I did have one thing, I wish they put some thing for the filter on there, pocket for the filter, but they don't. Anyway, but the bag works. It is good. It's has some serious padding on it. It does protect the system. The mount. So last time doesn't really carry one. It doesn't have one for the mount per se. It doesn't have a bag that's specifically for that. I found on some people recommended getting a food storage bag, kind of a pizza bag. Anyway, I did look for one. This is the only one I could find that actually had the right dimensions for the foam inserts right out of the box. Anyway, it works great. And then the other thing is tripod. So whenever I go somewhere, they sometimes sell the bag for the tripod, but I'm not sure what to do with the spider bar, which is probably the easiest thing to break on it. So anyway, so I just use the tabletop tripod when I go somewhere, and it works fine. Okay, important thing about the telescope is it's supposed to be expandable, and in particular the camera is going to be upgradable. There is no camera to upgrade to yet, but I guess I'm reading online to be in the next months to year time frame. I actually said that here last year, so we'll see. Not sure I would spend more money on right now. But anyway, one thing that it does not do that I really do wish it would be video stacking, time lapse, those kinds of things, or mosaic. People ask for the idea of mosaicing, doing some imaging around those. Another telescope, C-Star now supports that. Apparently that's not coming soon. And then labeling of objects in the field would be nice. But probably the thing that I would most like is some kind of video stacking or time lapse. Really, especially for the planets. It would be nice if you could. I mean, certainly you can take the raw images and stack them. It'd be nice if they supported that somehow within the system. But anyway, they don't. Here's the backyard versus darker skies. All the images on the left in all of these are taken from my backyard where it's not in the city where it's not at all dark. It's not terrible. My yard is not good. And on the right is a picture of leaves. So this one, this is at one of the state parks up in the piney woods, and looking through the trees, and it's about half the time, and you can see a little bit more, so that's good. But it's still not bad, even from my backyard. And here's a picture of M67, and then at spring break, we were out actually, this is from Junction, Texas. This is Santiana River State Park, which is a dark sky, international dark sky state park, and it's pretty amazing. So there you go. I'm 67. There you go. I should probably move that. Okay. So obviously it's a lot nicer. A darker sky. And 64 is really obvious. In my backyard, you can see the black eye there a little bit in the black eye galaxy, but it looks a lot nicer. Well, you guys can see these. I'm gonna have to walk. And then M51 again. So we're out in Carlsbad and for spring break. And M51, you can see quite a bit more. So just right after that, just would like to walk through some images that we have. So here's a picture of the moon, and so this is actually just Wednesday night. I replaced what I had here because I like these better. So this is just a couple nights ago. At the end of the night, I was like, the moon's there. I should have been imaging dark sky sites and not dark sky. I should image the moon because it's right here. I did one snapshot, that's it. And then I just went into Google Photos and cropped these. So, here we can see Plato, and we can see the Alpine Valley. And then over here is Copernicus. You can kind of make out the twin peaks there, the double peaks there. And then over here is Gassendi, Mare Humorum, and a few more here. Messio and Messio. You can't really see the shape of them too well here, but it's also not the right time of the month for the best. They're not anywhere near the. You can pick up the shapes a little bit, but it's also not near the Terminator. And on this side we have Aristarchus and Herodotus, and then here Tycho and Schiller and all that stuff. So just wanted to give you a flavor for what you can expect. Again, it's not the highest resolution, but not too bad. I like the fact that you can clip it and kind of show people what you're looking at. So here's Jupiter again. It comes out really, really small, but you zoom in and zoom in. You crop it very, very small. And it turns out it doesn't look too bad. You can see the rigorous on here and all that kind of stuff. So, not great, not bad. And here's Saturn. This is a different kind of thing. So here I'm not doing a snapshot. Here I'm integrated, so it obviously overexposes the planet, but now it allows me to pick out a few more moons than Titan, a couple more, Diana and Maria. And here's Uranus, easily pick out Titanium and Oberon. It's capturing Titanium and Oberon. And Pluto, easy enough to image from my backyard. It's not difficult. I put here the best image that I had of this Schuchenson Atlas. I actually have one with the anti-tail, but this is the best image. That's quite an image. So all right, and we're kind of moving farther away. So in general, I just put these in order of distance from the Earth. So Crab Nebula, here's M7 and from my backyard. So similar to Star Trek, but not the greatest sky. 46 with a foreground planetary nebula. And 35. Double picture photo it's talking about. And Caroline's Ring. And then for planetary, M27, Double Nebula. Or the Apple Core Nebula. It looks more like an apple core. And then it's going to wash out there anyway. But anyways, this is the first one, obviously. And then Rhine and Nebula in the Rhine. Elephant String Nebula. From my backyard, which is, that took a little while to image that. To get it to show everything quite down. And then we're moving into some nebulae, the Triplet Nebula, Rosette Nebula. Here we go, and it's emission and Dark Nebulae, and it's embedded open cluster. It's the Eagle Nebula. And then gradually, well, just one I put in here. 22. See that you can resolve it pretty well. And then moving out into galaxies, there's Andromeda. That was actually from state park is down here. Brussels spent. Probably not the greatest thing. And then here's from my backyard M33. That's pretty cool. You see quite a few things in the galaxy itself. And then Filter Galaxy. Moving farther away, not much farther away, M82, Starburst Galaxy. Ursa Major. M101. And GC 891, which is one of my favorites. And then Sunflower Galaxy M63. See quite a bit of structure now. And then GC 293, which is one of my new favorites. Again, from a dark sky site. And that's one's pretty. Lots of structure. Sombrero Galaxy M104. And the MGC 3718. Structure. Environment here. Well, this is not going to have skeletons here. You get some interacting galaxies here. So, this is a close up of that. You can see. And then other things we can pick out are supernovae in distant galaxies. This image shows up, and then I just add some markers to it. I've enjoyed finding quite a few of those. And then quasars. There was an article actually in Sky Telescope. Years ago about this is the most distant thing maybe amateurs can see. I don't know if that's really true, but anyway. It was pretty easy to go find it. I think I got one probably hand put in there. But anyway, easy enough to do if you have to. So, that's it. As far as images that I wanted to share, I'll do it back and see if I get questions. But otherwise, just wanted to say I use this telescope a lot. I have other telescopes, and I mean, I have my 8-inch, but it's a lot of work to carry out and set up. This one, you just put it together, walk out there, turn it on. I don't have to worry about eyepieces or anything. Just go out there and turn it on. Admittedly, there's some, you use it in a certain way, so there's not a lot of flexibility, but there's a lot to look at out there. So I use it to operate, and if these are shared images with multiple users, even later. And I have a tablet with a pen for pointing. So I have taken this out to Brussels Bend, to George Observatory on the Republic nights, and it's kind of nice, I think, because people can come by and show a picture, but also we can also, when's this one shooting? We can go back and say, here's what I'm shooting at tonight. And I find that kind of a neat way to show people what it is. And it prompts a lot of questions from folks about the things that we're looking at, which are. Anyway, I think that's all I had, except if you want more details, all sorts of images, but also detailed telescope information comparisons between the C-Star S50 and the Origin. They're all here in lots and lots of detail on my website if anyone wants to. All right. Any other questions? Go ahead.
So the interface is similar to the C-Star through an app?
Yes.
Okay.
Yeah, you exactly use your phone or your tablet, and it's all through Wi-Fi. It's very much the same concept, but different features.
So the ones where you had done your crop, right? You obviously did that afterward.
Well, they're different. Yeah. But
okay. So is there a way where crop and then image in a smaller?
There's no way to do that. And the cropping you can either do in the app for the ones that are stacked, or I do them if it's a snapshot. You have to do it also. Yeah, there's no region of interest.
Yeah, that would be great.
You're going to bring it to Mari to the open observatory?
Where?
Brazos Bend?
Brazos Bend? I don't think so.
Oh, okay. All right.
I thought about it. maybe in a week or two.
What was the aperture again of it?
It's a 6-inch aperture. 6-inch.
Oh, okay, 6-inch.
Yeah, so when they came out with the first question I had was, when are they coming out with the 8-inch? I don't know if they are. I think just because of cost and probably weight, but more or less mostly cost. It's probably not the cheapest thing to make. So.
Any other questions for him?
All right. Thanks for letting me come, Tom.
Well, thanks for sharing that with us. Trevor, what's the chance that the backup button actually goes backwards?
Yeah, it's pretty short.
Alrighty.
Yeah, it's great.
I'll have some backup stuff. Okay. I have a DIY astronomy topic, radio astronomy at 12 gigahertz. The Trevor and Phil factor. Just Phil. You guys have no idea what I'm going to say, do you?
I got a hint earlier in a text.
Number one, Trevor factor. So some time ago, Trevor asked me, he says, hey, can you do radio astronomy with one of these satellite TV dishes? And I said, oh, no, Trevor, no. You can't do that. The dish is too small, the frequency's all wrong. You can't do that. So, rule of thumb, anytime somebody's telling you something can't be done, there's probably someone out there that's already doing it. So, if you look on the Society of Amateur Radio Astronomers webpage, you'll find this project called the Itty Bitty Radio Telescope, which does exactly that. Number two, the fill factor. So sometime we were at Mod Pizza, and I was telling Phil, hey, Phil, you know something you can do in radio astronomy is you can measure the temperature of the moon with a radio telescope. And Phil said to me, he said, so why haven't you done that project? Why haven't I done that project? Why haven't I done that project? Okay, so combining the Trevor and the fill factor, we're going to attempt to use a satellite TV dish antenna to measure the temperature of the moon. Okay? Yeah. First question is, can a satellite dish be used to detect celestial objects at all? So how about we try with something that's really bright like the sun? It turns out, yes. This is a plot of time versus amplitude. So time is in time, like real time, hours, minutes, seconds, during the day. This is the sun going across and makes this little bump. So yes, you can use satellite dish and you can detect the sun. Now, there's one thing, I did this particular sun crossing on March 22nd. The spring equinox is on March 20th. Anybody got any idea what might be a problem trying to detect the sun with a satellite dish antenna around the spring equinox?
It's going to be in the plane of all the geosync satellites.
Who said that?
Forrest.
You got a prize. That's exactly what it is. You take a satellite dish when the sun goes across the equinox, it's around 0 degrees declination. You start pointing the satellite dish at the sun, which is right in line with all these geosynchronous satellites. You pick up all these satellites. So you got to figure out what's the sun, what's the satellite. Very good. Force, you get a gold star for tonight. Okay, second question is there a chance a satellite dish could be used to detect the moon? Okay, so here's a plot. Here's the moon along here. This is amplitude versus wavelength. So all the presentations I've been giving you guys in the past, I've been operating down here, kind of in the 21 centimeter wavelength range. But over here at around 12 gigahertz, or 2 centimeters, the moon is actually like 100 times brighter. Even though I've never really had very good luck detecting the moon with my other radio telescope, over here it's 100 times brighter, so there's some hope this section might work. Third question, can we use the software-defined radio for our receiver? So, these things, this is going to operate somewhere in the 12 gigahertz range, right? But the software-defined radios are in this range, so those aren't going to work at all. Those don't match. But it turns out that this gadget that's on here, this horn antenna, is not just a horn antenna. It's a low-noise block. So included in this block is a local oscillator and a mixer, which knocks down this input 12.7 gigahertz, uses a 1.25 gigahertz local oscillator, knocks down to 1.45 gigahertz. So yes, you can use the output of one of these with a software-defined radio. Okay, the fourth question. How can you power this? Because you got to power this thing, right? It requires power to make it work. It's got this amplifier and mixer all the stuff in here. How can you supply power in the middle of this line going between the antenna and your radio without blowing up the software-defined radio? And how you do that is you use a thing called the bias T on I bought it from Trevor's favorite place, AliExpress.
My favorite
Yeah.
place.
Trevor says he wants
Especially
to
now.
What?
It costs too much.
Okay. Anyway, so you use a power supply on this bias T, and it'll supply power to this thing, but then it'll let the RF through that will go to your radio. So here's the signal chain. We got this dish antenna with this low noise block. We got a bias T, a power supply, and it goes to our radio. It hooks up to a computer, which runs some kind of software that runs your radio, your software-defined radio. I use NPR Sharp, the average plugin, but you can use other software. That software. Okay. So here's a picture of this whole setup. Here's the computer. Here's the software-defined radio. Here's a bias T, and there's a cable going to the antenna. This thing is a cooling system. You don't need that. That's just something that's in mind. This question: how do we know where the antenna is pointing? So if you look at these satellite dish antennas, they're some kind of weird oblong shaped or oval shaped, and the antenna's off at an angle here. It's not a parabola, so it's not like you're pointing straight at it. So I noticed that on the bottom of these things, there's this little plate down here at this angle. I was thinking, I wonder if the people who made this thing were nice enough that they would make that plate so it just happens to be pointing, in the direction of the antenna. And thank goodness they did. Whoever made this thing, this plate is actually perpendicular to the direction that this dish actually points. And so that means you can put a protractor on here with a weight on it, figure out where your declination is up and down, and then you can use a compass to line this thing up north-south with the meridian. So you put it north-south and then use a compass to get declination. Because these nice people put this plate on the bottom here. It allows you to do that. Making measurements requirements. So you need to know where the moon is going to be. So you're probably aware, maybe not, the moon changes its declination every day. It goes up and down during the month. It's all over the place. So you have to look it up and find out what's going to be the declination of the moon, which means the same thing as latitude. Declination, when it crosses your meridian, your local meridian, the line goes from north and south over your head. Where's it going to be in declination for that day? And you can look this up in any planetary program like K-Stars or the Sky Solarium. Any of those will tell you where the moon's going to be that day. Then you need to find a usable frequency. It turns out that I was looking through these frequencies range here. There's all kinds of satellites that we want doing this, and then a satellite would pass through, a couple seconds of man-made stuff, obviously man-made signals, and then go away. And this just happened over and over and over and over again. But it turns out that 12.7 gigahertz, which might be 1450 on SDR, it's actually clean there. So you can do that. So this is what it looks like sitting up. There's a cat hanging around. All right. Then, using the moon's declination at transit, how do I set my protractor? What you need is you need to know your local latitude, you subtract the moon's declination, and that's your protractor setting. So, for example, if I'm at latitude 29 degrees 36 minutes, which is where I am, and the moon's declination for that day is 4 degrees 24 minutes, you subtract that, it's 25 degrees 12 minutes. So that means you set the protractor so the south is straight up. Here's straight up. You set it 25 degrees this way to be pointing at the moon when it's transit. Okay. Making a measurement. I did it with SDR Sharp. I have average software. You can use whatever you want to use. It's not critical. In this case, the IF average plugin, it actually creates these files, and you can plot these things in Excel or MATLAB or whatever plotting program you like. And that's how you make plots you're going to see. Okay, so here it is. This is the moon, and this was a plot of the moon a few days ago. And as you can see, this is actually a pretty decent signal in the radio astronomy world. So this is the moon going by, and I've got a nice signal here. You need to remember this number, 0.063 dB signal noise ratio from this point down to the noise. That's how big the moon was. And this is time going along, so the moon's passing over, passing by my meridian, it gets real big, and it passes by, and it goes down here, right? So two things, I got this amplitude, but also I can tell something about the beam width of this dish by looking at how this thing is shaped. It tells me basically how wide my beam is. We'll need to know that too here in a minute. Now, how do I take that measurement to determine the temperature of the moon? The whole thing, I want to know, how can I find how hot the moon is? So, I'm going to show you the calculations on how to do this for two reasons. One is I can't be outdone by Chris Randall by not showing you guys equations down here during my presentation. And second thing is, I want this presentation to be complete. So if one of you guys want to go out and actually do this yourself, do this project yourself, I'm going to give you the whole thing so you can actually go out. If you have a dish on town, you want to try this, this is how you can do it. So the equation is just the temperature of the moon equals T, the effective temperature, which I'm going to define in a minute, divided by R. R is just simply the ratio of the size of the moon over the size of your beamwidth of your antenna. So the beamwidth antenna is like this, the size of the moon is like this. We know that the size or the area of the circle is pi r squared, right? So the moon is a half a degree across, the radius then is a quarter of a degree across. So pi r squared of the moon, that's going to give me the size of the moon in the sky, the angular, solid angle of the moon in the sky. And then if I know my wavelength and my diameter on the Sarah Society for Amateur Radio Astronomy webpage, they have the instructional videos and has this nice little formula to help you figure out what the half power beamwidth is, which is how big this is here, this circle here, how many degrees it is. And that's the diameter, take it by half, pi r squared again, and r is this number here. So that's the ratio of the size of the moon to the size of my beamwidth. That's how I find r. Now, T, effective T is where I want to get to. But you have to know two things, T total and T sys. T is the system noise of your system, especially how noisy is my system all by itself. And there's this nice equation over here that you can use to find what the system noise is. You have to know T hot, which is, in my case, I took the side of a garage and I measured it with my antenna. I put a thermometer up here, I can measure it's 82 degrees, and that's what my T hot is. That's actually the temperature of that wall. T cold is I'm going to turn around and point this thing out into space. T cold we're considering to be 10 degrees Kelvin, right? So T hot, T cold are actually physical temperatures of these things you're pointing at. Y is the other factor you need to know, and that comes from the software you're using. I look at my software, and when I'm looking at the hot thing, I figure out how many dB does my software read off T hot. Okay, so I got power hot dB, and then when I point at something cold, what's my power cold dB? And that's these two numbers I can solve for Y, where I have those two numbers. I just read it right off my software. Okay? And then this is all done in Kelvin, so you got to take the 82 degrees Fahrenheit, convert to Kelvin. You put this into this nice formula, and that's what you get for T6, 257 degrees Kelvin. Now, I'm still trying to get T effect. This is the last slide of math, so hang on. All right, so I need to get T total. T total is calculated by this original thing I showed you, the plot of the moon here. There's a factor called delta T dB, which is basically the moon's decibels above the cold sky, basically the signal noise ratio of the moon above the cold sky, which wound up being 0.063 dB. I put that in here, and I can solve for T total, which is this. Now I've got T total like a T sys. T effect is T total minus T sys, which is 3.75 Kelvin. Okay, so that's the whole bit. There's the T temperature of the moon. It's the T effective temperature divided by R, and I get 151 Kelvin is the temperature of the moon that was measured using this method. Now, is that correct? Is this what we would expect? So, look at a couple references. This book, Radio Astronomy by John Krause, shows the moon, and it changes over the phase of interval. There's new moon, first quarter, third quarter, and it changes as you would expect as the moon goes through its different phases. But for our wavelength, we would expect this thing to be about right in here, which would be about 200 Kelvin. So I got 151 Kelvin, which is not exactly 200 Kelvin. And you say, well, it's a satellite TV dish, what do you expect? That, right? But so I was going to tell you, tell you guys, oh, I'm so sorry, that's as good as you can do. But then last night, at 2 o'clock in the morning, I thought, I figured it out. So, I'm sorry. And so here's another reference of another guy, and he just got it right above 200 Kelvin also. All right, I got ahead of myself there. And he was operating at a wavelength very roughly close to the wavelength that I'm operating at. So similar results to John Krause. But where could we be making an error in our method or calculation? And what I thought, okay, I use this equation from the Sarah webpage to calculate my half power beamwidth. But in addition to that, I actually have this thing here. I actually can measure the half power beamwidth from my measurement. Because I see as the sun going across, I can figure out, well, where does it have power? Right here. And if I know the time between these things, because the Earth turns 15 degrees per hour, I can then calculate what the degrees are for that beamwidth. And it turns out the beamwidth was a little bit off. So if I take this, I find out now the half power beamwidth is actually 3.75 degrees from this measurement I made. So my antenna would work exactly perfect according to the equation. I plug that in here for my new R, and I get 210 Kelvin, which is just about the same as what these other people got from their measurement. Yeah. So that's this is a satellite TV dish, right, guys? I mean, this is something I hang on that ours has been on the side of our house for 30 years unused, all right? And I probably told you it's worth fine. So, if you want to go home and do this, it's a pretty cool project, I think. Phil, that's Chris. What?
Well, that's a circular polarized horn. So, how would a linear horn do?
I don't know. Lucky to get this to work. Well, okay. So the moon and most celestial objects are unpolarized, right?
So you got to take into consideration that your polarized antenna is only going to accept so much of the information.
The circularly polarized.
Yes, they're just going to accept only so much of the information.
Well, okay, but I got the right number. I don't know. The answer is I don't know.
How did you take into account the temperature of the dish itself?
That bothers me too. Okay, that's another I don't know, but that bothers me a lot.
Because radio astronomers worry about that all the time.
Yeah, exactly right. I was thinking about that. The dish itself is like either you're doing sun or things out in the sun.
Yeah.
It's hot, right? I don't know. I don't get that either. But that bothers me because I actually measured the garage. But what I did, I put the dish in the shade, right? I measured the hot, wall of the garage. But it does bother me that no one seems to care about the actual temperature of the metal of the. Rick, do you guys know the answer to that?
No, but the one thing I was going to mention is I know in the big telescopes, the big radio telescopes, what they do is they take the sensor and they run it down to a couple of degrees above 0 Kelvin.
But that isn't it. He's talking about the dish itself.
Yeah, but they don't do anything with the dish either.
Right. Like the dish itself is blazing hot.
Yeah, there's absolutely no way to
throw everything off.
I don't know what that is.
Lance, do you know?
Only thing I figure is the dish is just a reflector. So
Well, the dish is radiating an infrared,
Right.
and that's far away.
You make it. Yeah, you're right. Okay, you're right. Okay, so what happens is Jerry's got a relative that works at Green Bank. The way they paint, that's right. They paint those things. That's what it is. They paint them so they radiate in certain wavelengths, but not other wavelengths. Okay, that's what it is. So I read about that. That they paint this thing a certain way. It gets hot, but it doesn't radiate in the wavelengths you're concerned about. Yeah. Okay.
Now, paint your dish and do it again.
What?
Paint your dish.
Do it again. Paint your dish and do it
I
again.
got the right answer. I'm done.
Have you figured out what caused the difference between the calculated half power beam width and the measured?
Absolutely. So the calculated one, what I did is just assuming you have a circular aperture and the thing is a parabola. Okay, that's what that calculation gives you. This thing is not a parabola; it's oval. It's a weird shape, and the antenna's like over here.
It's an offset parabola.
And yeah, it's an offset parabola. It's something, and it is, and it is not, because you look at the shape of this thing. That is not a normal Gaussian shape like what I get on my other radio telescope. I usually get a nice Gaussian shape. This is some kind of steep, weird thing. And so the response to this antenna is doesn't apply to that equation.
So I'm missing the whole point of using the equation in the first place. Why wouldn't you always just measure it off the signal?
Because I didn't think of that yet.
Well, no. Why would they have this equation?
Because most normal people use a parabola with, with their antenna right in the middle.
Okay.
See,
It seems overly complicated. But it just seems overly complicated, but I don't know very much about it.
No. Okay, the equation does work because my other ones, it truly is a parabola, and the feed antenna is right in the middle of the thing, and it is right on, like within a minute of being right.
Okay.
So it really is right, and it makes a nice Gaussian shape too. Okay, but this thing is not a Gaussian shape, and it's not a parabola. It's not really even a circle. It's an oval. So I think that equation will not work. It's like the equation for resolution. Like for circular axis, it's 1.22 times wavelength divided by diameter. That's only true if the thing's a circle. If it's an oval, that equation doesn't work anymore.
That's why.
Okay, any other questions about this before I move on? I'm almost done. Okay,
I'll
right there. Hold on.
I think it's incredibly interesting and it's remarkable ingenuity, the whole bit there. And I'm glad you know what the temperature of the moon is at that given moment, etc. Can you use this for anything else, though? I mean, because it'd be nice if you could use it for some other kind of exploration or whatever. Is that possible?
Okay, with a satellite dish, no, but the way they found out the temperature of all the planets is using radio astronomy. When they say, "Oh, Mars is this surface temperature, Venus is this surface temperature," that's done by radio astronomy. They do the same thing, but they use a real radio telescope, and that's how they measure that's how they get the surface temperature of the other planets. Does that answer your question?
Yeah, pretty well, I guess. It'd just be nice if you could do some of the things with this jimmied up setup that you're already doing with your more sophisticated intended stuff, you know what I'm saying?
Yeah. The whole advantage of this thing is it's at 12 gigahertz, which, like I said, the moon is really hot at 12 gigahertz. So in my other one, I've done moon crossings a whole bunch of times. I never got anything I could say is really the moon. But it's 100 times brighter. You know, that's going to be significant. Okay, young lady up here.
Can radio astronomy be used to find about the temperature of like faraway stars and planets and stuff like that that's outside of our galaxy?
That's different. You can actually do that optically. You can actually look at the spectrum of a star optically and you can figure out what its temperature is. Yeah. Okay.
Did you look at the sun and get its temperature?
No, and here's why. The sun is not a black body radiator. It is, but okay, the sun's a black body radiator, but it just has all these magnetic fields and electrons flying. So the radio emission from the sun is not all black body radiation. It's all this other stuff that's going on there. The moon is actually like a black body radiator. It's just sitting there getting illuminated by the sun and it heats up and all that. But the sun's got all kinds of crazy stuff going on. It is not. In fact, hold on. John?
It has spectral line.
You are not paying attention.
Oh, he said something. Oh,
didn't you read this chart? Like active sun. Oh, look at the chart. Here's black body radiator, right?
Yeah.
Look at this active sun. Right? It's like all over the place. There's all kinds of stuff going on with the sun. The moon is just a straight line.
Well, quiet sun is almost.
It's still not black body radiator.
Good, it's solar moon.
Yeah, it is black body radiator, but in addition to that, it has other things that are radiating more in our frequencies. Okay, anybody else? Rick.
Is there a way that you could, in a half moon, you're going to have where the sun's on the moon, you've come up with that temperature. As you move across, it's going to reduce in temperature, but it reduces fairly slowly. Is there a way that you can actually create a graph to show that?
Well, the beam width of the telescope is like 3 degrees, and the moon's like half a degree.
Oh, okay.
Yeah.
So the answer is no.
No, not with this. If you had really high resolution with a greater telescope, you could.
Okay.
Yeah. Al, did you have something?
Well, your original premise was, could you do this on the cheap? I know you already had the SDR. The dish probably cost you $15 on Craigslist, and then what? You had to buy that one thing from Alibaba, right?
Well, okay, the dish was on the side of our house, which I bought 30 years ago when we started the dish network. And I just took it off there, so I don't know how much I paid for it. The little doodad from Alibaba, whatever, is like $12. Everything else I had. Yeah. Okay, any other questions?
Was the LNB the one that came with the dish?
Yeah, it was. So, you guys know something unusual about this picture? There's only one of them on there, right?
Right.
Yeah.
Why is that?
You took one off.
That's exactly right. So what I originally did, I took one of these things off. I wasn't going to talk about this. Like, probably going too long, but I took one of them off, and I thought I'm gonna put it on my big dish, you know, the one that's the 2.1 meter dish, and I'm gonna use this thing, and this is gonna be the best thing that ever happened in the world, right? So I put this thing on here, but it turns out Chris was actually the one that turned me on to use hardware cloth instead of chicken wire, which Jerry told me to don't do that. He's right. But it turns out 12 gigahertz, that hardware cloth doesn't reflect anything because it's 6 millimeters, or 0.6 centimeters, and then the wavelength is 2 centimeters. So it's the 2 gigahertz goes right, or 12 gigahertz goes right through. It doesn't reflect it. I got no signal on it. I point at the sun, I got nothing. Right, with the big dish on it, because you need a solid dish to do this. Does it have anything to do with what you asked me? Oh no, I brought it up. Okay, yeah, so the reason that horn is gone because I took that horn off and put it on the big dish. Didn't do anything. Forget it. I was the one that asked the question. So. Wait. Okay, so any other questions? Oh, wait. Okay, so conclusion, a reasonably okay signal can be received from the moon at 12.7 gigahertz with a satellite dish antenna. And the temperature of the moon can be measured with relaxed precision. Not really great, but okay. If you measure the half power beamwidth is used instead of using the other one, the measured half power beamwidth, and you have a lot of patience to mess with this. Okay, so future projects. If I find another one of these Dish 500 things around, I can make an interferometer. So if you guys just happen to have one on the side of your house and you don't want it anymore, let me know. We'll make an interferometer.
Bring it to you.
You got one?
I don't know if it's the same one, but I've got one on the house.
It's got to be the same.
I don't know if it's the same.
If it is the same, that'd be cool. It's Dish 5. This 30 years old. Dish 500 has 2 horns on it. If you got one, let me know because it'd be cool if I had stuff making an interferometer, except for another dish. And then they make a 39-inch version of this thing. Mine is 20 inches. So if you have a 39-inch dish, you can actually get better results. And I could actually, I'm thinking about doing water masers too. You do water masers with a larger dish. Okay, any other questions or comments?
I got one.
What?
So, if you do the interferometer, how far are you going to space the dishes?
As big as my yard will let me, which I don't know how big that is. But yeah. So Lance, you're being very polite not to make an obvious observation here.
Well,
is there something obviously wrong with what I've done?
No,
there is something.
I mean, but you know, for interferometry, you really want to be at least miles apart. Right?
Well, it's not going to be miles apart. You can make an interferometer in your backyard.
Yeah,
it'll still be bigger than what I got.
I just won't have the resolution.
Well, I know.
But it works.
It's a satellite TV dish, right? Okay. Anything else before we move on? Move on. All right. So Paul Maley is not here, but he supplied a members minute to us, which I'm going to present. Paul Maley's members minute. JSC expedition to the Canary Islands for March 29th, 2025 partial solar eclipse from Paul Maley. Okay. So here's the pink path of the eclipse. The pink indicates 80% plus of the sun was covered, decreases 0% if the background is white. Okay. Here's where Paul was. He's on near the Canary Islands down here, off the coast of Morocco. This is what the weather was supposed to look like on eclipse day. But luckily, at his location, this was Paul's actual weather, so it looks like he lucked out. There was one problem: is this sign of bad luck was a black cat that was seen on eclipse memory. And here's Paul and then out photographing the eclipse. There they are by the pool. That's some pretty good. That's luxury astronomy with your feet in the water. All right, and then he says everybody else is unaware the eclipse is even going on. And here's this picture. Success maximum coverage 19.2% captured. Paul. This is his 86th solar eclipse. Next one will occur September 21st in New Zealand. So Paul, if you don't know, runs a company called Eclipse Tour. He takes people out and you go on all kinds of expeditions all over the world and see eclipses, sometimes on boats, sometimes in the desert, sometimes just all over the place. So if you want to go on one of Paul's expeditions that's coming up in the future, you can go to this webpage and find out all about those. Nice plug.
All right. Next, Ron is not here with the DVD library. Okay, so it turns out Ron actually has been having significant health problems, so we kind of keep Ron in our thoughts and prayers. We may not be seeing Ron again, so just be aware of that. But Ron's asked us to figure out what to do with the DVDs that were in the DVD library. So if you guys have any ideas of an organization or entity that we could donate all those DVDs to, please contact Ron and tell him what your ideas are. He's trying to figure out what to do with the JCAS DVD library. So. All right. Did you bring a Sky Telescope magazine?
I sure did. There's 5 of them up there in the corner.
Excellent. Thank you. Those are free for anybody that wants them, right?
Yep.
Thank you very much. Okay, so we're going to take a brief break, 5-minute break. Okay, the meeting after the meeting, we're going to shoot up Middlebrook, go left on 13 Boulevard to get to Mod Pista, and find everyone's welcome to come to that and talk about astronomy and other things. We'll take a 5-minute short break and we'll finish up this meeting.
Is it getting that late that we got?
So I talked to you. Let me get out of your way here. Trying to do some exhausted. I actually so it's between these two. So I'm gonna have to count it.
Oh, you're doing it.
Thank you.
So these two kids, they are going to
Saturday.
Probably. We're only juniors, whatever. Whatever it will take.
Yes, so right now,
It's interesting.
get it flat. It's good. So
right. Not this thing.
yeah. Same fire for me. Drive you.
Professor, all this stuff every quarter.
Oh, that's right. So what do you want to know? Oh, okay.
So, we have the and but he has other telescope and whenever somebody he brings up a telescope and look at and show you the you know how to use it? You know how to use it?
My instructor so he's actually started
That's not fun. Get rid of her.
That's a great hat. Not a very good yeah, but also it's like I don't also you actually give a problem and wake up and it's everything in the middle of nowhere, it's dark, trying to follow those
Here or somewhere, you know,
how do you go there once a year? Just start
I don't.
so whenever and
Go to yeah. Metals are important in that. So you can't build fire.
website's hard to navigate. Well, you just kind of play around, you know, survey, start playing, until you find what you want to find. And it's kind of complicated. It's a bunch of simple programs that you can do, like everything else you do. You got to do it.
I looked for stuff to try and make my it's like there's only so much you can lose. I'll definitely check out.
Yeah, they got all kinds of survey programs now. You have to be a member to get the award. Do them, and then when you become a member, you can spend your stuff.
Right, but even by watching it.
That's like your short. Yeah. The most important thing I'm gonna say right now is get you a journal.
So if I bring this
Think
thing
about your journal, date, time, sky conditions, what you looked at, how it looked, and right now. I'm trying to get advanced report with a change for the advanced reports. I'm having to do wrong and everything. So I'm having to dig back to all my old stuff and fill in all the wrong because I'm not going to go out and go through all that stuff again. But that's not going to be.
I've only kept it for like years.
Like, look at some other partners, have the information they want later on. It gets all the way down to the bottom. They want to like totally random and tell you what the number is. Now, look at this. I would advise you to be in order to I want you to go back on the past. Like one of them says no, only 2 items before the state equal action. Some of them have restrictions, like on the pipe included areas, some have restrictions. I don't want you to do different things for the same object. Sometimes you have to do the same object times this would be strange. But always put all the requirements in. So put all the requirements in the log your log. Do it. I advise putting it in a spreadsheet.
Yeah.
Yeah, just go back like I'm doing. Go back to all books and try to find all the dates and times. And create the information based on these issues. I didn't have to report all the stuff.
You know, I saw another member and showed me his Excel file and all the things that you observe and links to the pictures. So it's not the same. I
That does that. Excel's not that hard. It's all short.
My dad uses Excel for a living all the time, and every time he tries to show tests, it gets so frustrating. It doesn't like me so much as like
Once you get used to it,
yeah,
it's
Okay, we're gonna get started.
Camera was just and on the logbook page 1, entry 1, I did this object.
Right.
That way you can find it easily. But I get
no, that makes a lot more sense.
We're gonna get started with the second half of our meeting.
Nice to meet you.
I think it looks like it is.
We'll catch you.
You guys are giving me a complex.
Where's your little shaving
Yeah, I didn't want to get it out.
Shaving
I
thing.
thought you guys would just behave. I'm bringing her along.
Shaving stick. You know better. Oh, don't tell me you're going weak on it. Start going to work. You're going nice on it.
You were the worst offender. Sit down.
You have to excel at something.
Okay. All right. So next up here we have Jerry, who's going to tell us about the JSC Fort McCabe spring trip that they just got back from. So join me and welcome Jerry.
Fort McCabe. Return. Yeah, hit the enter button to go forward, back. Backspace to go back.
Okay, got it.
Can you find it?
Yep, got it. Thank you. Well, I got appointed to tell about the Fort McCabe trip. And I'm giving a presentation, and at least for our part in it, my job was to set up the equipment, kind of help make it work, and kibitz while Behan did all the photography. So the credits go to her. And also I want to acknowledge Brandon and Swin Chu, who helped us
when things didn't work right with the troubleshooting. Okay, so this was the star party on Saturday, which is one of the reasons we go. The participants from our club were Ken and Lisa Lester, my group here. Brandon Flumin Chu, you all may not know, but he's been to some of our star parties. He's one of my colleagues in the pathology department at UTMB. Mark Stein, and there was a guy from San Antonio whose name I did not get. So that was the 8 of us, and the public were 9 people and 1 dog who came at different times of the evening. But they were quite engaged and I think very appreciative. So otherwise, there were really 3 great nights, Friday, Saturday, and Sunday. Thursday was kind of rainy and windy, but the other nights were nice, at least in the first parts of the night. So this was the group at the grilling and potluck on Saturday. You can recognize some people there, hopefully. And this is the lineup of telescopes, most of them along the ruins, as you see on the left there. And Brandon was out in the parade ground with his big telescope, his big dog. The sunsets were really nice. This was a sunset where there was this cloud that was kind of characterized as a whale and dolphins. Another really nice sunset. And again, a sunset with the thin moon up in the sky there. So the rest of it, I'm going to show you, are the pictures that we were able to get. And this is the equipment that we have finally come up with that we can make work after quite a bit of struggling with other mounts and telescopes, cameras, and so on. So this was the Red Cat telescope that we have fell in love with, and the rest of the equipment is all ZWO, including the ASI Air, which really helps us a lot to find things and get things aligned and take pictures. So the pictures I'm going to show you are all done with live stacking, and these were all targets selected by Bihang and photographed with the aid of that software. Here's the first one we were able to get was the Leo triplet. There you go. And one of the nice things about the ASI Air software is that you're able to label things with it. It knows exactly where it is and what you're looking at, even if you don't. And this is where it is in Leo. The Orion Nebula and the Pleiades. We were able to get the Whirlpool Galaxy also, and the Cigar and Bose galaxies in Draco. And then, since there would be a test, so anybody recognize this one?
57.
Okay, so this is known as the Owl Cluster, and it is in Cassiopeia. And it is characterized as an owl like that, and some people would like to show the owl's prey. Over to the left there is the 2 little mice. But there's another characterization of that. Cluster. So this was most of what we did, but last night Bihang stayed up really late until Virgo came up so she could get Mercurian's chain in Virgo. And you can see all of those galaxies. And that was our experience with Fort McCann at this time. Probably the most things we've ever really been able to do there. Good. That's it. Thank you.
Any questions for Jerry? You must have done a good job, Jerry. All right, Al's going to give us our What's Up in the Sky in February plus recent astronomy news.
So we're in April. And the constellation I'm focusing in on is Virgo. And we always start off with meteor showers, and this month we actually have one, the Lyrids. I think I read there's about 28 meteorites per hour, so it's not one of the biggest ones. One I've never really looked at. And the main thing is that with meteor showers, they span several night periods. So if you have like a clouded night, you can still see meteors on another night. So there's that. So I start off with binocular objects. And I don't like this map here very good. It's actually located, let's see, Rose Cluster. It's the south-southeast of Virgo. And this is Serpens here, the SER is there. I'm not sure. The maps of Serpens that I have it's more off to the left, and that Virgo's off to the right here. But I tried to get a realistic picture of what the Rose Cluster looks like. And the reason why it's interesting is instead of being a bunch of like dotted stars, it has more of a circular feature to it with the brighter stars. So I think at the end, after a couple pictures here, I show it zoomed in. The second one that I picked was M68. And so these are pretty realistic pictures of what you would see in binoculars. So it's not really distinct and big like you would see in a telescope, but it's still something nevertheless you can find with binoculars. So I would love to talk more about globulars. Doug, did we have somebody that did a talk recently about globular clusters and the ages? I thought that was really fascinating about some globulars are old, but there's some young ones out there. They started to break down globulars into all sorts of different types, and it's just so fascinating. I mean, when you look at a telescope, they all look so similar, but then they're actually so much more distinct, especially when you do photography. So when I pulled up these really pretty pictures of them, you don't really see in the Rose Cluster, but it forms a little bit of a ring here with these reddish stars here when you look through a smaller telescope. So in bigger, brighter objects, of course, I like galaxies a lot. And one of my most fascinating objects that I ever looked at in telescopes was the Sombrero Galaxy. The previous guy took a couple pictures of that I'm going to show. And on the right is what you typically see in a good-sized telescope. A lot of times the dust line is a little bit obscured and doesn't look as bright and distinct as this right picture. I also showed this in a previous talk a couple of months ago about how they're using the microwave, or the array, the VLC, what is it called? VLA. And they're using the Webb to look at the different sizes of the dust particles. So some parts of the Sombrero has small dust particles and some has big, and it's very interesting to see the distinct differences. But when you get into bigger class telescopes, like if you can ever look at a 25 or a 31 inch, this, with your naked eye seeing this dust lane is just incredible. There is not another galaxy that I know of. There's a couple that are smaller, but not as big as this one, that have such a distinct dust lane. There's others that have fuzzy dust lanes, but nothing like this one. And so that's a really cool object. So almost every telescope can see the Sombrero Galaxy. And this one was talked about earlier. And the right picture here is really neat because if you look at this, I think I've looked at it once, but it's called the black eye because this darker ring that's near the center here kind of looks like, I guess, a guy's been socked in the eyeball. But I just really like that color photograph there because it just shows so much more to it than what you see in a telescope. But of course, that's probably like Hubble picture on the left. Now, I put in a couple of planetary nebulas because I love them. one of the reasons why I got into astronomy was because I just really like planetary nebulas, and it's such a great thing to do if you get some time to read about them. They started to try to understand more about the structure. Basically, a lot of planetary nebulas were some exploded gas, but then through some secondary explosions or nuclear processes, it sent out more energy, and that energy is hitting the cloud that's already been produced, and that's why you get these interesting shapes. The blinking planetary, they named it that way because if you look at the picture on the right, you can see the two bright objects you see real distinct on the left. And as you do your averted vision on ground-based telescopes, a lot of people would see those little bright objects to the left and right kind of come and go, and that would make it look like it's blinking in your eye. And so big deal, right? When you can see this really distinct in larger telescopes, it's interesting to look at the structure. But what I've noticed is, in my more recent years in astronomy, is when you have a picture of the object and you can look in the telescope and you can stare at it for a while and really think about what you're seeing, you really start discerning more of the structure than you would have if you just looked at it really quick for 3 or 4 or 5, 6 seconds. So I like looking at these pictures, and especially the newer Hubble pictures. It's odd, but when Hubble first came out, they were so interested in looking at faraway objects and things that they couldn't look at before that it was only in the background they started taking pictures of more of the larger, more interesting objects that astronomers like us like to see. And so it's kind of neat because they're not really studying this picture at all. It was just kind of like an afterthought. Well, we got some extra minutes here. Let's do some pretty pictures. And so I think it's really fortunate we get to see some really cool things in the Hubble now. And this is one of my favorite ones. So we're having a field trip or a astronomy trip out to X-Bar Ranch here at the end of the month, starting on the 24th. And last year at the eclipse, I rented a couple rooms at the ranch, and I had 2 pristine nights. And I mean pristine in the sense that the scene quality was way above average, and the quality of the sky in the sense of like not very much turbulence helped me see all this really brilliant structure like the photograph on the right. It is something interesting when you can look and see the structure of the planetary nebula instead of a little fuzzy ball, and I just thought that was so cool. So that's why I included it today. Right now in the spring we have Virgo and Leo coming up for a long part of the night, and so you can see a lot of galaxies and a lot of planetary nebula and other objects like that. So it's really one of the fun times in astronomy is in the spring. So I always include a couple of really smaller, obscure objects. Arch galaxies or arc objects are usually very small, usually 12th magnitude and less bright. But in larger telescopes, it's really incredible to see these interacting galaxies. We only have about, I don't know, less than 5 or 6 large interactive galaxies like M51, the Whirlpool Galaxy, which are 2 interacting galaxies. So unfortunately, most objects are so faint that you have to have bigger telescopes. But it's so cool when you get a chance to see in a larger telescope some of these interesting objects. So on the left, I tried to include, these are from the ARC book, from I think some surveys, and that's how he found some of the objects. So the image on the left is what you normally would see, but it's so cool to see what the higher quality telescopes image can produce and how really cool they are. And when I look at these, I try to see if I can find these filaments in between the 2 galaxies, because, once again, if you just want to quickly look through a whole bunch of objects in the night, you're missing a whole lot of what is interesting about astronomy, which is to look at the objects and try to see some of the features. It's a little bit of a test and a little bit of work, but it's worth it. So now we're going to go on to, I have 3 recent astronomy news objects or items. This last month or 2, there was not as many really cool discoveries or things being published. But one of the ones I found really interesting is NASA just put up this new satellite, which is an astronomy type satellite called SphereX. And it was taking me quite a bit of time to study and investigate exactly how it's built and how it works. But essentially, it has a field of view 20 times wider. So the top 3 pictures are the same as the bottom 3 pictures in the field of view. So it has 6 detectors, but they couldn't tell me what the top row is from the bottom row. But I know that the top 3 represent the visual size of the sky it's looking at. What I did find out is that even though Webb and Hubble have been focused on far away, distant, redshifted galaxies, this has been put up in the to orbit the planet so that we could look at and do more of a survey of galaxies. And so they were saying something like, well, one is it takes a lot of pictures. Second thing is that some of these pictures are going to have thousands of objects in them. And they said that something like 100,000 detected sources would be captured through the survey they're trying to do. So I don't know. It's just so interesting. This pales in comparison in cost to what like the James Webb Telescope costs. And so it's just really interesting how we're going to fill in more knowledge. I don't know. I couldn't figure out exactly what the plan is, like what they're going to use the survey for, but they just got it launched, and these were part of the test photographs that they're using to make sure that the culmination and everything was perfect, so they were getting perfectly sharp objects. So typically, you know, they're very excited when something works, and then it takes years of data later to find out exactly what they learned and what they figured out. The next one is, has anybody seen objects like this before? I've already shown 2 Einstein rings. So an Einstein ring is produced when a perfect alignment between 2 galaxies or objects. It could be a quasar, which the other guy showed a picture of a quasar. I didn't know that they were easy to identify in a picture, but because they're usually very small, but very magnetic or energetic. So in this picture, the center is an elliptical galaxy. So elliptical galaxies generally don't have spiral arms and don't have anything but look like fuzzy ball. And you kind of see it in the center here. And in the background, way far away, is a spiral galaxy. But so this is a James Webb picture. So this is all false color. So there's no orange, and there might be green, but there's no orange. But the blue is how the rings got lensed. So the back spiral arms are so wide compared to the central object that they look distinct and normal. But the blue lines in the center are the parts that got lensed. So what they say is the back object gets bent by the magnetic field of the object in the foreground. So there's usually some aberration in the picture that makes it distinct. And so, I don't know. I just love them. The third one and last one is Perseverance. Apparently, there's been a lot of dust devils on Mars. And this is just an interesting little video. So there were 2 here that were spiraling around, and let's see if this video works. And what they thought interesting was there was one following the other, and then they merged. And I see a third one in the far back too. And then if you look off to the left, there's one over there too, which they didn't mention, but was mentioned in my research is that they're happening all the time. But generally, the rovers aren't meant to do a lot of video taking. This is a special thing where they were trying to capture this in multiple exposures to make a video. Because normally what they're doing is still photographs and doing zooming in and stuff like that. So occasionally when they find some other science questions and objects, then they go and change their parameters. So the one in the foreground is about 200 feet wide, and then they said that these were imaged like a kilometer away. This gives you an idea of what kind of visual
field of view they've got on that. Okay, thank you.
Okay, so Chris agreed to give David Star Party news for tonight. David couldn't make it, so Chris agreed to fill in. I fear you guys get tired of hearing me talk all night long, so Chris is going to save us on this one.
Yes, I remember instructions. Okay, past events, we have Magnolia Creek Golf Course. We had Fort McCavitt Triplet. And TSP is coming around the corner. X-Bar is coming around the corner very soon. And then coming up the next hack will be a Sunday. Sunday on June 8th. Because they're having weddings on Saturdays, so it's hard for us to get dates on Saturdays. And then August 1st will be a Friday. And then you got Okie-Tex, another hack, another Fort McCavitt, another Okie-Tex, and an Eldorado Star Party. So that's fun.
Okie-Tex.
What?
You put Okie-Tex on it twice. I don't know why.
Hey, I didn't do it, so.
Yeah.
And then November, we got the Moon and Sun Night at the George, and then another Magnolia Creek in November. And so here's some pictures from the Mag Creek thing. There's your illustrious president praying to a telescope. And John Gorduke. Oh, there's a picture of him. And the sky, you can see our little setup. We had a good time there. And some people got some new sea stars they're playing with. More of us. And notice I don't have my big scope there because it was windy when I was going to pack up, so I brought my small scope. But we had a good time there. And there's, I believe that's, I don't know who's that is. Is that yours, Reed?
Yeah, that's fine.
And then that's all, folks. Any questions?
Doc, can I make another mention of the X-Bar thing coming up?
That's what we're going to talk about next.
Oh, good.
Did you want to say something about it?
Up there and down here.
Okay.
What do you want to say?
Oh, I just wanted to invite everybody. I don't know if we're going to have enough people that are going to look out the ranch, but there's still other places to stay. And I'm going to be there at least 4 nights. I might end up being 5 or 6 nights, depending on how the weather looks. And we always have fun there, and there's going to be at least 4 or 5 people with good-sized telescopes and photography if you want to learn about photography. And we're usually pretty friendly and like to show people stuff. So, I mean, just what I always tell people about start parties is that, you know, you don't have to bring a telescope. You don't have to even bring binoculars. You just have to come and then be nice and maybe bring a little bit of food and have some fun.
So, Al, you're going to this one? Okay. So, Al, since I'm not going, but since you've been there so many times, why don't you kind of like shepherd the newcomers when they get there? I'm going to tell them how it works, but, you know, if you keep an eye and help people who's their first
Yeah,
time.
we've been doing this through an email list, and I didn't yet put my name on there as being like a contact person. I know the people that run the ranch, they'll probably be out a couple of days while we're there. I did let them know that we were having like a small little start party. One of the main reasons why we were doing this is because the Texas Star Party increased their costs so much that we thought, well, we don't need to go for an entire week and pay so much money. We could probably like go to X-Bar Ranch and just make a small little kind of field trip out of it. And it's a little bit more comfortable at the ranch than it is at TSP because a lot of people camp out because that makes it cheaper at TSP. So anyway.
Okay. All right. So I'm glad you're going. All right. So we were asked to put together some information about the X-Bar trip. It's Thursday, the 24th this month to Sunday, the 28th, 4 nights. So there's 2 things that occur at the X-Bar Ranch. So let's make sure we're clear about this. In the fall, there's the Eldorado Star Party, but that's not what this is. Anytime you want to, you can go out there on your own and do an astronomy trip. They have cabins, they have RV spots. You go anytime you want to, but in the fall, they do have a big shindig called the Eldorado Star Party. Okay, so the way this works, if you look at this, during the El Dorado start party, it's about 150 people typically that attend. There's this ranch area up here, which we're going to talk about. There's some cabins and things we're going to talk about here in a moment. But down there, and there's a small observing field here, which is what you guys will be using when you go out there this month. But at the El Dorado start party, you walk down this path here, and there's this large observing field, and that's what's used for the other people at the El Dorado start party. But for this trip, here's a picture of the area where you're going to be. Okay, so there's a lodge, which is right here. It's called the Live Oak Lodge. And then around the lodge, there's all these cabins. When you rent one of these cabins, you get one of these. There's some here, and then one over here, and one over here. And then there's these RV spots, which are right here. Okay, and there's a bunkhouse, which you can get if you rent one of the other cabins. That's a long story. We don't need to worry about that. Okay, but the observing field, we're going to set up your telescope, is behind the lodge. It's back here in this grassy area right in here. Okay? Where is X-Bar Ranch? If you left here from UH Clear Lake, it's 6.5 hours, 412 miles. You basically just go west forever on I-10, and then you exit 388, go north on 21, 29 for 7 miles, and turn the right-hand side. If you look at that picture I just had, what's going to happen is the entrance to it is actually here. It's going to say, it's an X-Bar Ranch and Nature Center. You get off here and you drive this little big gravel road down here, and then you come down, drive down to where the lodge actually is. But this is FM 2129 here, 7 miles north of I-10. Okay, so how do individual astronomy trips work when you go here? What you do is you go to the X-Bar Ranch webpage and you make the reservations. You can get a cabin, you get an RV slot, things like that. You just go there and make your reservations. When you arrive, you go into the lodge, which is the big building in the middle, and the keys for your cabin are going to be sitting on top of this table. You walk in there, there's a table right there. The keys for your cabin, you're going to know the cabin number, like you got cabin 5 or cabin 6, wherever. There's a number on the key. And then you're supposed to sign this release form. They have a little form for you to read, and you sign. Basically says you won't sue them if you get bit by a snake or something. You got to sign that, and you got your key, and then you're ready to go. You put all that back there, or actually just leave the keys in the cabin and leave. So then you go and you set up your telescopes in the small observing area, which is behind the field. Okay? And you need to obey normal stationary rules that everybody does at all the other star parties. One thing, you need to tell the X-Bar staff ahead of time that you need electricity on the field. I'm assuming, Al, I hope you tell them that we're going to be doing astronomy, because then they'll actually run the cables out there for us. If they know you want to do astronomy.
You weren't necessarily going to do that. You can, with a 100-foot cord, get from the buildings to the...
You can.
So
you can do that too, but if you tell them ahead of time, they'll put cables out for you. So if I was you guys, I'd say, hey, we're going to do an astronomy event, and they'll put those cables out for you. Okay, so telescopes, it's okay to put down tarps. Mike says, is it okay to put a tarp down on this grass? Yes, you put a tarp down, and you can stake your equipment down. Please stake your equipment down so you don't make all of us cry. Because I can tell you the people in this room, their telescopes have been blown by wind and busted because they didn't stake their equipment down. I'm not going to point everybody out, but I know who you are. So stake your equipment down so it doesn't get blown over and get busted, please. Okay. All right. Dim red lights. So in the lodge, during the daytime, there's all kinds of lights and stuff, but at nighttime, they got these little chili pepper red things up along the lodge, and you can turn those red lights on, so the lodge has a nice dim red light, and you get in and out of the lodge if you want to. Okay. Okay, in the lodge is a full kitchen, which you can use the kitchen. There's a refrigerator there, which you can put your food in if you want. There's also refrigerators in the cabins. The TV there, if it's a cloudy night, you can't think of anything to do, there's a TV there in the lodge area. 2 normal restrooms, lots of tables for you to sit down and eat food. Ice and snacks are available for sale on the honor system. So you see these snacks sitting down, there'll be a little coffee can right there, and then ice is in the freezer, and there's a coffee can on top of the refrigerator. You put your money in there and you take it back ice. Mark?
I'm gonna have an RV spot. Does the lodge have a shower?
No.
The lodge doesn't have a shower. You'll have to get a shower from somebody who has a room.
No. Okay.
Yeah, during the star party, the main field has public, big shower.
It's just the bathroom, the toilet.
Just the bathroom. Okay.
Yeah, and if you want a tent camp, what I'd recommend you doing is rent one of the RV spots. If we run out of spots, which I think there's only 2 or 3, we'll get approval from them to have another way to pay for an RV spot and be able to tin can, which is I think less than $35 a night or $40. But that's full hookups too. So anyway.
Now, I should say though, during the El Dorado Star Party, at the other field I showed you, the big field, there are showers down there. So when you go and there's 150 people, yeah, you better have a way to take a shower. And so down there at the other field, there is an outdoor shower. And it's it's fine. But for this individual trips, you're pretty much on your own shower. Yeah. Okay, the cabins, the fridge, there's showers in the cabin, normal restroom. The windows, that's important. The windows are covered to block the light in the cabin. So if they know you're doing astronomy, they'll make sure that the windows are covered in the cabin floors. Hiking, the green trail is the one. There's 3 trails. I think it's red, green, blue, maybe. But the green trail is the one that's maintained, is pretty good condition. It's about 3 miles around. When you go out on this thing, and when you're at the Expo Ranch, watch out for snakes and scorpions because they're there. And we can tell you snake stories. I mean, I was walking down the green trail one time, not paying attention to what I was doing, and I looked down between my hiking boots. This gigantic, what was that? I forgot, rat snake, something? I don't know. I forgot what it is. It was a gigantic snake between my boots, and I jumped, and the snake was scared, and it was bad. One time we were there, and that guy right there rustled a rattlesnake, right? It was a rattlesnake.
A baby rattlesnake in a
in a bucket somehow. He was out there near the observing field, got in this bucket, took it, threw it over the fence. So if you see snakes, go see how he eats them. Go see Alan, and he will get rid of snakes. He seems to not be afraid of them.
Well, that one came out from under the step on the lodge.
Yes, he was under the steps of the lodge, and Al got the thing out of there. I don't know. Anyway. So there's snakes and there's scorpions. So watch out. Scorpions just stay around the edge of the observing field, but just watch out for them because they're no fun. I advise having hiking boots because this place is rocky and the rocks are sharp. I've worn my tennis shoes around a little bit, and that was a mistake. Don't do that. There's snakes and scorpions. There's sharp rocks, and it hurts your feet if you don't have hiking boots. There's also cactus out there too. So let me tell you, I don't know how the cactus always get in my socks or in my legs somehow. I never get anywhere near them. Cactus everywhere, but you need to have protective clothing or else you'll be miserable. Nearest town is El Dorado, obviously El Dorado, and Sonora. Sonora, they're both about 20 minutes away, even though they're different distance. But it takes about 20 minutes to get both of them. There's more restaurants, grocery stores, and gas and stuff in Sonora, so I go there. If you need medical attention, there's actually a small medical center in El Dorado. So that is that. Any questions about this?
I want to add something, Doug.
Yes, please.
So normally during the ESP Star Party in October, all the cabins are rented already, but most people do 2 to a room is because of the cost. Because all of the rooms have enough beds or whatever for 2 people to sleep. So if people want to like double up or whatever, it'll totally work. I don't know. If you're a light sleeper, it's hard. But the other thing is, if you want to get a real hotel room, Ozona has nicer hotels than Sonora. And better than those 2 cities is San Angelo has a lot of hotels, and it's a very large city. But anyway,
San Angelo's the closest Walmart, I think, isn't that true?
Yeah, and Target and some others.
I think so.
Good restaurants up there.
Right, but it's a lot farther away. So, and we go most of the time we go to Sonora. There's a lot of nice things there. The Pizza Hut in Sonora is kind of iffy. Sometimes open, sometimes not.
Oh, and so I'm going to put my name on the email list, but if you haven't been on the email list, get on there as soon as possible, and you can go back and look at some of the chit chat that we've had about it and the trip. And as things get closer, we'll be talking about the weather, and I'll bring some games, and I'll make sure we have some fun activities if we have a bad night and stuff. That's typically kind of what happens. It's hard to get 4 perfect nights. It's usually like 2 good nights, an iffy night, and a kind of a bad night. So we just make the most of it and try to have a good time anyway.
Right. Bring all your own food. There's actually, in theory, if you rent a cabin, you're supposed to get a continental breakfast. There is some free things in the refrigerator that supposedly are the continental breakfast, but I've never quite figured that out. But okay. Any more questions about the X Bar trip this month?
I think the S bar has Wi-Fi.
Yeah, absolutely. Yes. Yeah. Good point, B. Thank you. It does have Wi-Fi and also cell phone coverage too. Yeah. Any other about the X Bar trip?
Does it have Wi-Fi in the field?
Yes.
Or just in the campus?
Absolutely. And actually, even at the El Dorado Start Party, even out at the other field, there's Wi-Fi. So they're really good about that. I mean, it's not really good Wi-Fi. It's good that they have Wi-Fi, but it's bad Wi-Fi. But it's good to have it.
Yeah, they have some of the repeaters mounted to the cabins, so they can get it out to the field.
They actually use the same antenna, which is my first radio telescope. They have the same one. Anyway, okay. Anybody else have something to say about the X Bar trip? Okay, good enough. Okay, next month, May 9th, we'll be right here. We're going to have an LPI speaker, so it's going to be really different than tonight. This is an LPI scientist who's going to tell us about revealing the earliest era of the solar system, isotopic records of the planetary formation process. So compare that to what we did tonight. We have a lot of variety. Okay, door prizes.
Get your door prize ticket out, and we will get going on this thing, and we will get out of here. All right. Anybody not get a door prize ticket? Anybody not get a door prize ticket? Dan, you did a good job. Thanks for being our door man. 4, 9, 8. No. Who's that?
Early.
3. Is somebody speaking? 4 and 8? Somebody late. No. That's too many people here. All right, next. 5, 1, 8.
Oh, that's